Alright, question 276. Successful lubrication. When examination should be made by the engineer to ensure the successful lubrication, how should the feeder with all the cups of adjust? Successfully lubricate the bearing of the locomotive with all the examination necessary to see that all the oil holes are open for the sufficient amount of the oil is given in the bearing, just enough to properly lubricate them and the preventing the cutting of the spring of the driving the box cellars. The tender truck box for the engine truck with the cellars should be saturated with the oil and have enough elasticity to remain in contact with the journal. The top of the driving the engine truck box should be backed with a good quality of the cotton weight of the oil saturated with the oil with the packing should not be distributed except for the absolute necessary. And in the case of the removal from the top of the box, carefully should be exercised to prevent the dirt from entering the oil holes, getting in the bearing, and is advisable to help the end of the packing and sponging. Turn down on the edge of the cellar, driving the engine truck box to prevent the waste from working in between the journal brass from forming the wood zone of the waste crabs, keeping the packing of the becoming glazed hardened in the cellars there should be. Our method of packing driver the engine and trucks shown. Figure 1 is up and figure 2 is low figure. A and B show the packing. No trouble. Driving the engine truck cellar with the often packed with the shown figure 1 to give it the very satisfactory result of the tender truck box with the running successfully when packed and shown figure 2. Loose rings and saturated waste in A, the pack put in the back end of the box must be served to keep the dust out of the dirt of the oil. The sponge of the B should be placed between the ring and the first applied with the collar to the journal, but they should never be extended quite to the center of the journal. This part of the sponging should be built up at the square edge of the collar without any of the red contact. The waste should be put with the front of the box at the end of the journal. The hole of the spring of the sponging of the in place for the method to prevent the collar of the journal from pulling it on the sponging from the back of the box. So the feeders of the oil cup should be adjusted to feed as the small amount of the oil will run the pins to coil, but at the same time should be the constant pass of feed. Otherwise, guided closely. Otherwise, gauge too closely. Supply may not reach the bearing at the proper type of the sufficient quantities. Trouble will result for the cylinders if the drive steam with the lubricator for the soup with the speed of the surfaces in accordance with the size of the cylinder. And advisable adjust the crack joint with the throttle valve with the opening enough to prevent the smoke of the gases being drawn with the cylinders and steam shaft of the drifting of the will be reasonable success for lubricating the engine. Question 277. Effects of the heat on engine oil. What is the bad practice to keeping the engine oil too close to the boiler head of the warm weather or in warm weather? Because of the increase of the temperature of the oil will make from the very much thinner, and the new lubricate will not lubricate the bearings as well as when in the normal temperatures. It will only run through the sponging more than rapidly, leaving the waste of the top of the box dry. Over the box dry. Question 278. Effect of the changing position link on the indirect motion engine. What effect would it have on the valve of the indirect and eccentric wood with the connected the axle in the front of the length instead of the behind them? In other words, the eccentric is the same as the position relationship to the pin, only with the link behind the eccentrics instead of the head. An inch of the motion of the valve would be the same as the exemption of the lever that hooked up toward the center of the lead with the degree for the same portion that would increase the eccentric connected with the axle behind the links, and otherwise the effect of the valve would be the same in either case. Alright, question number 279. Regulating the draft in front of the end of the engine. I wish to inform you that I wish you would inform me on how the draft should be regulated with the front end of the engine, but only with the petticoat, the sleeve of the hanger of the front end, how the sleeve of the petticoat pipe should be handled to increase the draft near the flues, to increase the draft near the firebox. Can you regulate the draft from the petticoat pipe sleeve? Must you have one or both of the purposes? In front end of the no diaphragm, the lowering sleeve you will give the top of the draft through the flue will reach farther back to cause the fire to burn better, with increase the draft through the back end of the firebox near the door of the rising. Raising the pipe will increase the draft through the bottom of the flues, causing the fire to burn more than near the flue sheet. Lowering the pipe will decrease the draft near the flue sheet. After you get the fire burning evenly with the grate, the draft is not strong enough to burn the fire, but the engine will stream steam freely. The draft may increase. Moving the pipe up and the sleeve down will increase the draft after you get the fire burning evenly with both the sleeve and the pipe. That should be used. If only one is moved, you will get the fire burning evenly on the grate surface. Again, the more you raise the pipe and lower it, and the sleeve, the stronger will be draft. The more the lower the pipe, the raise the sleeve, the lighter than the draft on the fire. Alright, question 280. Difference of the engine, the same type. I am firing an engine called the Monacan Rebuild. We have two of these, two of them in division, same type of putting them in the same way, same size cylinder, the same amount of the heating surface, the grate in front end arrangement. One of the engines steams fine to the light and in coal, while the other steams poor and heavy on coal. Where will I look for the trouble? Alright, answer. Certain with the flues of the boiler, they're clean. With the flues are open, the boiler free with the mother scale. If the check of the paper with each of the examine the seam of the pipe with the exhaust pipe with the leak joint should you have find that to be all right. Achieve that the joints of the smoke box are tight. The stack is in line with the field, but equally on all sides when the engine is working. Note that the valve motion and all the and find that if the valves are set in the same with the same lap, if they have the same inside clearance to the lamp, at the same time the valves are given by the inside clearance to such that the extent that the seam is permitted exhausted earlier before this performance of work and should be similar. In the case you do not find the trouble in the valves, examine the piston and the insertion if they have the same thickness as some of the good engine with the cylinder heads, and so we'll know the cylinder clearance are the same on the both engines. But if this does not lubricate the trouble, that you will need the indicator to help define the defect. That you will probably find with someone with the above mentioned cause of the being responsible for the difference of the two engines. Calculating the horsepower of the engine. In the study of the steam engine, I found the two different methods of calculating horsepower of the engine, but according to my figure that do not give it anywhere with near the same results. I wondered with the pleasure to have the opinion of which was correct. The rule given with the Hawkins has his studied steam engine follows multiple area piston with the square inch of the average force of steam in the pounds of velocity with the piston with the feet per minute with the divided in the product of 33,000 pounds. 7 times for the quotient equals with the effective power of the other rule of the multiple mean with the effective pressure for the piston length of the stroke with the feet multiple in product area with the piston square inch multiple aging again with the number of the strokes per minute with the divided in last product of 33,000 pounds. In other words, the plan method of your example, the plan is 82 pounds. P is equal to 82 pounds of steam pressure during the length of the stroke. L is equal to 3.5 feet length of the stroke. A is equal to 907,922 square inches. Or 907.922 square inches the area of the piston, and is equal to 45 strokes per minute. In example, the plan is equal over to 33,000 equal to 355.3 horsepower. And so the rule given in the Hawkins identical with the above. Therefore, both rules are correct. This is termed indicated with the horsepower to designate the work done by the steam. Then taking the 7/10 of the quote in earlier, in either case you will have 248.71 horsepower is expressed for the total available power of the engine, allowing the 3/10 to overcome the friction of the engine. As available, the horsepower is less than the indicated horsepower amount absorbed and overcome the resistance and friction of the engine. In one formula, you made allowance for this in the other engine. You did not account for this difference. Or question 282, finding the diameter of the circle given in the air. Given the rule of the full, finding the diameter of the circle when the square and the surfaces are only are known. Answer, suppose you desired an area of 12 inches for the weather to determine the diameter of the circle that will contain the 12 inches. The area of the 12 inches are divided by 7.7854 or 15.278, and the square root of 15.278 is 3.908. The inch of the diameter of the circle will contain the 12 inches of the area of the, as written is square root of the area over 0.78254 of the diameter of the circle. Question 283. Position of the eccentric different motion of the place given the position of the eccentric inside of the indirect, the inside direct, indirect, and the outside emission of the indirect motion again. Answer C, diagram page 199. 284. Eccentric most likely to slip. Which is the eccentric most likely to slip? To go ahead with the back of the which way will it slip? And the forward motion eccentric when running forward to the back motion eccentric with the running backward because of the more nearly the line of the block of either motion. Therefore, controlling the valve, you can readily understand when the engine of the full gear forward with the forward motion eccentric right near the line of the link block with the working moving the valve is done with the forward with the motion eccentric within this portion of the work will hold the good relationship with the position link block in the link within the link. The back motion eccentric is only holding the bottom of the link with the work done with the back motion eccentric with the very light with the lever in its position. Are the illustrations of the different motion, the inside emission, indirect motion, the inside emission, direct motion, the outside emission, indirect motion. When the slip axle is usually slipped back with away from the work with just same the man walking forward and pulling a load would slip backwards. If the walking backward under the sum in condition would be slip, he must be forward. Our question 285. The AN042 engine was what is meant by a 042 engine? Answer, the engine of the two pair of the driving wheels. The engine extend with the back of the far enough to provide the small coal water space for the tender for the one pair of the wheels are under the same wheels arranged is shown in the following sketch. The diagram of the 042 engine. Alright, question 286. The right and left hand brake of the beam with the fulcrum. What position does the man assume with the religion of the brake beam fulcrum determine if the right and left hand brake beam of the fulcrum? Answer. If you stand at the end of the car with the rear of the tender with the line with the drawbar, the face door of the engine of the brake beam, with the tongue outside of the wheel, with the fulcrum of the lever of the brake beam, at the angle of the car, with the top of the lever to lean forward to the right side of the engine of the beam would be the right hand brake beam, and if the top of the lever to lean toward the left, it would be the left hand brake beam. And some of the manufacturers have a letter cast on the fulcrum and the brake for the brake, rather designating them for the right or left, with the right left. Question 287: setting of the eccentric on the road. What is the best and quickest way to set an eccentric on the road? Answer: placing the engine on the forward center of the side of the eccentric slip of the forward motion. Eccentric with the slip of the pull of the lever in the full gear forward, opening the cylinder cock with the cranking the joint with the throttle opening with the move the eccentric ascent till the steam show with the front of the cylinder cock with the back motion. Eccentric head slip and the lever the back of the gear with the move with the eccentric until the steam show with the front cylinder cock. The quickest way to get in with your train, placing the eccentric forward to give you the better chance to get eccentric with the piston is given is it forward end of the cylinder seam of the emitted with the forward seam of the port over the more engine, either the backward or forward. Alright, question 288, angular advance for the eccentric. I am told an answer to my question. Valves in their trouble. The angular advance for the eccentric with the amount of the center of the eccentric with place ahead of the center axle. I do not understand the center of the eccentric being placed ahead of the center axle. Please answer. If you place the engine in the forward center of the draw the vertical line through the center of the axle, the place for the center of the bolt of the eccentric in line with the line and first drawn through the axle, then there would be no angularity of any kind of advance. The eccentric in the case would be set at the right angles at the pin. When the valve to the lap of the eccentric must be advanced toward the pin. If the rocker arms are equal to the length of the lead, the angular advance must be equal to the lap. And the lead valve of the line drawn with the head of the vertical line first drawn the distance equal to the lap of the lead, but the center of the eccentric avoided the lines of the would-be angular devices. You would find this more fully explained in the Arts of the Railroad published in Railway Publications Society, Chicago. Question 289, main equalizer fulcrum. What is the proper name of the inverted T-shape of the mechanism, both in the frame running through the middle of the main equalizer between the driver of the eight-wheel engine? Main equalizer fulcrum, the proper name for the sometimes called the equalizer post for the post of the equalizer standard. Question 290, difference in pressure differential different parts of the boiler. When the boiler under ordinary conditions under the steam pressure says 100 pounds, are all the parts of the boiler under equal pressure? If there is any other more pressure on some parts of the boiler than others, yes. The bottom part of the most pressure, steam being elastic exerts and pressure evenly in all directions, but the bottom part of the boiler supports the wave of the water as well. The steam has the most pressure upon it. Question 291, expansion of the air steam system. Expansion of the air and steam. How much difference of the expansion of the air than the expansion of the steam? The difference between the steam condensing when it comes in contact with the cold walls of the cylinder being much greater for the condension of the air. The difference depends on the temperature of the steam and the walls of the cylinders. Question 292, lead. If you give the sample engine of simple engine lead with the place for there here on the forward center of the left side, then place the lever in the center of the quadrant. Do you come over the seam of the port? I claim as you will pull the lever toward the center of the quadrant, the engine on the center of the keep the opening of the port wider than until the center of the quadrant is reached. Then the port is open wider when the lever is in its corner. Answer: you're right. How hooking the lever toward the center increases the lead opening portion to the radius length. The increase the greater the short eccentric rod, less than the long eccentric rod. Question number 293, blowing low pressure cylinder in Schneider cross compound. How would you test the blowing of the low pressure cylinder in the Schneider cross compound? Answer: make the test for a low pressure cylinder, move the handle with the operating low valve with the simple position, test the usual manner with the simple engine. Question 294, ports are not covered with the valve. Can the ports and the engine have the lead over the cover of the valve when the engine is dead center? The lead is the down for the opening seam of the port when the position is being within stroke of the lap of the mount of the valve is extended over the outside edge of the seam port with the valve is inserted in the center of the seat. If your engine has neither lap or lead, eccentrics would be set at right angles to have pin, but also have both advance and eccentric toward the pin. To pull the valve back with the valve with the lap, then advance it still farther with the given leading open to the side, looking in the side of the engine. This is on the dead forward center, but it can be readily seen with the engine that has left when the lever is full gear forward. Pulling the lever back with the quadrant will push the lever the lower end of the rocker lever, the head upper rocker arm, and the proportion of the radius of the link. In other words, increase the lead as you hook the lever back of the mid gear, which increase the lever the move of the mid gear with the full back motion of the engine has led to both motions forward back in the ports could be seat and the cover of the side without disconnecting the valve wrap. However, the valves were set with the blade in one motion, blind over the other. The ports were covered with the levers motion. There was a set blind knot in motion that had the lead. Place the engine on the right forward dead center. Make the valve stand with the valve lever full gear forward that have the lever motion moved, and full forward of the full back motion when as marks on the steam lever is being forward moved. If set within the same lead for both motions, you can see that it would be impossible to cover the ports. Try it. Alright, question 295. Affecting lower diaphragm. What would be the effect of the lower diaphragm of the locomotive? That is, will it make a stronger draft of the fire? Will it cause the draft to be stronger than one place than when next to the flue sheet? Such a claim will be lowering the diaphragm in contract for the opening of the consequently, the air passing through the grates of the flow at a higher velocity through the burners and the fire more furiously. The diagram is the purpose of the regulating the burning of the fire, raising the cover of the strong of the draft of the back end of the firebox through the upper flue, lowering the cover of the stronger draft of the front end of the firebox, lower of the flues. In order to obtain the benefit of the heating surface of the flue, the firebox diaphragm should be adjusted to burn the fire nearly even over the great surface of the causing even the draft of the flues. As the water allows the bellows upward, but sometimes the advantage to have the different draft slightly stronger than the flow or flues. Although the diaphragm adjustment obtained with both results should be kept in position. If the engine does not steam, we desire the increased draft through the grates and all the flues, and it should be done with adjusting the fluid in the petticoat pipe at the sleeve. Although lowering the diaphragm would contact the opening of the increasing velocity of the gases through the lower flues in the front end of the box, it would be detrimental to the steam quality if the engine would close the heating surface of the upper flues, raising the bottom part of the pipe above the nozzle tip, lowering the top of the sleeve. Figure 1, Figure 2. From the base of the sack, increase the draft, raising the sleeve, lowering the pipe will decrease the observing of the Figure 1. A pipe, the sleeve extends from the base of the sack to the base of the exhaust pipe with the dotted with the broken lines representing the steam passing through the sack. This is not very large opening with the exhaust port that expels the smoke of the gas in the front end, but they are not thrown into the vacuum in the form of the air drawn through the grates and fill the vacuum in the front end. In Figure 2, we have the pipe. In Figure 2, we have the pipe raised above the nozzle tip of the sleeve, lower at the base of the sack, so the exhaust steam will expel with the gas at the front end with the greater volume. The air will flow through the grates and fire promoting the combustion. Consider the nozzle of the petticoat pipe at the sleeve. The stack should do the business in front end the same. The tube of the nozzle inject the adjustment of the tame to the satisfactory. If the draft cannot be strong enough, and then the manner of the nozzle should be pushed and put on account of the effect of the lack of the back of the pressure. The cylinder should be only done by changing the pipe at the sleeve. Will not produce it. Our question 296. Which wheel slips? Well, the wheels of the locomotive are fixed on the faster of the axle, the outside rail with the curve of the longest. How do the outer inner wheels keep even in rounding of a curve? If they're either slip or how much? Answer. If you were to ask how much surface the tire driving the wheel of the locomotive comes in contact with the rail, the answer of the various engine man would vary. Some would claim 1/2 inch, others would claim 2 inches come in contact with the rail. Occasionally we would inform that there were only a fine line over the point of the contact, which is correct. In order to get more of the point, it would be necessary to have the flat spot of the tire equal to the surface of the tire contact with the rail. Therefore, the tire is round. They will have only a small point of the contact. Locomotive tires are termed slightly conical until from the flange the edge of the tire with usually a 1/4 inch. That is, the small diameter of the tire would be a 1/4 inch less than the large diameter. If the point of the contact between the tires of the pair of the wheels of the wheel, the same distance for each of the flange diameter would be same. If the wheels then roll with a straight line from when the wheels strike the curve of the flange to the outside of the wheels, are brought closer against the ball of the rail, making point of the contact with the largest diameter of the tread. At the point of the contact with the tire, the rail will be in the smallest diameter of the inside of the wheel with the flange and farther away from the rail. For example, the wheel take of the pair of the wheels, which tires are 60 inches in diameter for the large diameter of the tread, 59 3/4 of an inch for the smaller diameter. We have the wheels of the flange near the rail moving the distance of 188.496 inches each revolution. When the wheels on the inside curve within the point of the contact with the small diameter with the flange away from the rail will move the distance of 187.71006 and over the set or 7.7854 of an inch less distance for each revolution of the wheel. Due to the difference of the diameter of the wheels and the points contact with the rails, as therefore 5.28 0 feet or mile and 60 inches wheels would make 336 revolutions per mile. Therefore, the difference in the 222 feet between the distance covered on the inside and outside of driving the wheel, providing the wheels came into contact with the rails described above, the lateral motion slide play between the face of the hubs and the driving boxes will permit the flange outside of the curve of the roller toward the rail of the diameter of the larger. Alright, 297. Underhung springs are a broken tire. How should the standard 8 American engine underhung springs that be handled in case of the broken tire? A spring saddle extended to the bottom of the driving box with the held in position by a pin. Alright, this is a poor design with the driving box for the case of the kind with the cellar rate, with the center, with the clear, with the seal, with the pin, with the support string saddle, with the pin extended through the box is held in place with the face of the axle, with the face of the shoe and the wedge. When the tire breaks, it still remains on the wheel necessary to keep it from the rail. It is broken from that comes off the wheel with the wheel slammer must be raised to keep it from being damaged. We will take the example of the forward tire broken. We'll insert the block between the top of the back of the box under the top of the rail and of the frame, taking out the cellar and see if we have the space enough between the spring of the saddle, the journal, and into the block. We hold the broken tire and from the rail. If not necessary, to remove the pedestal and the thimble bolt. Then run the back drive of the wedge raise the lower end of the pedestal jaw with the legs of the frame above the pin, with the take out the pin, with remove the spring of the saddle, with the cut out the block end of the timber. Then the tire will fill with the space between the pedestal bolt with the journal when this wheel will clear the rail. Having thick enough to allow the wear and settling, the chain the end of the equalizer frame and the run back of the wheel of the edge, and then point the pedestal bolt back into place with the tightened nuts. Now the wedge is under the wheel and the broken tire. And the run wheel is on it until you can insert the block between the pedestal bolt and journal. Run the wheel off its edge of the wheel, off the wedge, and you're ready to proceed. If the back spring is heavy enough to carry the load of the blocks, maybe remove the top of the back box and the back spring utilized. Question 298. Engine slipping with a heavy train. If an 8-wheel engine was down on her back boxes, would it have tendency to bank engine slip with a heavy train? An 8-wheel engine usually has about 1/3 of the weight supported by the engine truck, the other 2/3 of the support with the driver through the medium of the equalizer spring of the truck, supporting the weight on the front end with 1 point, the fulcrum of the equalizer on each side of the engine from forming the other 2 points with the forming the tripod with the distribute the weight equally on an even track. The 2 back points to support the place with the weight of the fulcrum of the equalizer with the transmission with the spring saddle with the hangers, and for the purpose of lessening the shock of the equalizing load of the rough track. 7. Each of the end of the equalizer for more support 1/2 of the load weight with the fulcrum. When one end of the equalizer moved down from the other end, move it up an equal distance. Weight of the support the same as the equalizer was in horizontal position. Therefore, an engine slightly low behind the down with her back boxes would not lose her adhesion more liably slip, providing the points of the support were same. The equalizing free to move the fulcrum if the load intended with the carriage of the drivers were transferred to the back boxes of the count over there. Being blocked between the top of the box and frame of the equalizing feature with the destroyer from the forward wheel would be support with little weight, and if any with more weight would be carried on the truck. The result would be less weight on the driver, which would be reduced the adhesion because of the engine slip. Alright, question 299. The sight feed lubricator. Does the oil feed through the sight feed lubricator go through the lubricator into the valve of the gravity and forced down by the current over the steam? Alright, answer. Oil that is fed through the sight feed glass lubricator at the top of the water with the glass about the reason oil between the later than the pressure of the weight of the water with the condensing chamber with a level is higher than level of the water with the chamber above the sight feed glass. The steam flows through the equalizing tube the force of the water with the condensation from the hole in the choke plug, keeping the water level opening as the oil rises at the top of the water oil above the level is forced through the choker into the oil pipe leading to the steam chest. When the pressure of the lubricator end of the oil pipe is greater, the oil is carried through the steam chest with current steam pressure, the oil being heavier than the steam that would flow through the chest of the gravity without pressure of the steam, but the movement of the will be slow. When the pressure of the steam chest end of the oil pipe exceeds pressure of the lubricator end, the oil pipe is sometimes filled with water, forming with the term called pocket from the oil, preventing the flow of the oil chest until the pressure is reduced at the end of the pipe. The oil does not flow through the pipe, it appears in the glass. When the drop of the oil rises opposite side of the hole of the choke plug with the steam of the water atomized and is mixed in proportional with the amount of the oil and water with it passing through the choke of the valve and the cylinders get oil and water sample that can be easily obtained by disconnecting the oil pipe, starting the lubricator, replacing the bucket under the end of the pipe. For this kind of circulation valve, the devices ensure the positive circulation through the oil pipe with the lubricator to the chest and maintain lubrication under the various conditions. Our question 300: bridging exhaust nozzles. What is the difference it makes whether you put a bridge in the exhaust nozzle crossing the flues and parallel them? A bridge is used to spread the exhaust steam to fill the stack of the engine so the engine will burn her fire. Our answer: a bridge plate for the single nozzle has been effective with reducing air, increasing the back pressure for the cylinder, spreading with the steam of the fill with the stacked manner would have the tendency to further increase the back pressure, as it has been found with reducing the choke of the smaller diameter of the stack caused the back pressure for the same with reducing nozzle. If the stack is out of line to one side, the other plate with the edge parallel with the flues would gouge for the steam to fill with the stack that produced the greater vacuum, so that the stack was not filled with exhaust. Should the stack be out of line, either forward or back of the nozzle, then it would be beneficial to play for the edge crosswise with the flues, and would be better to have the nozzle stacking put in line. The expansion with the exhaust steam pipe would fill in evidently, bridging the nozzle, usually creating one defect remedy of the other. Our question 301.